Then we have direct expression for the velocity of a sound as root of gamma p by rho, where gamma is ratio of specific heats of the gases Cp by Cv, P is pressure, rho is the density of the medium. This is basing on Newton Laplace correction, where he assumed that propagation of the wave, where he considered that the propagation of the wave is an adiabatic process where the temperature doesn't remain constant. Now, I want to express this further using a equation, ideal gas equation, because it's going through the medium air, who is a gas, PV equal to nRT, where n is the number of molecules. For n equal to 1, I can write PV equal to RT. So in the place of pressure, I can write RT by volume. And also in the place of density, I can write mass by volume. So substituting these two things, velocity becomes root of gamma in the place of P, RT by V, in the place of density, mass by volume. So volumes gets cancelled. So I get expression for the velocity as root of gamma RT by M. Yeah, that's the equation that I have. So I want you to look at this equation carefully, because this is another format of understanding, right? From this you can understand. I want to tell you one important point, that if pressure increases in on any of a medium, that pushes the molecules close to each other, density equal to mass by volume. As pressure increases, volume decreases, because molecules comes close to each other. Pressure and volume are reciprocal to each other. As volume in the denominator decreases, density increases. So when you say a formula, velocity of a sound in a medium is root of gamma p by d, or density, I would like to tell you that the velocity of sound is actually independent of pressure and density combination, right? So they are not going to affect it. But as you have rewritten the formula in some another format, velocity of the sound is root of gamma RT by M. It's very clear that R is a universal gas constant, that is constant. Gamma is the ratio of specific heats, as I told earlier, so it depends on the nature of the medium. There are different kinds of gases, like mediums like monoatomic, simply hydrogen, helium. Helium is a monoatomic gas whose gamma is equal to 5 by 3. How do you get into that? We will discuss in the later stage, a different level. But you know this value, probably have learned it in heat. And then we have nitrogen, who is a diatomic gas. We show it like N2, whose gamma is equal to 7 by 5. Thus, it depends on gamma. Of course, R is constant. It also depends on molecular weight, obviously, for a gas. It also depends on absolute temperature. If you raise the temperature, velocity increases. These two are very well related to each other. I want you to understand this point carefully, right? Once after you understand these basics, we can further discuss this problem, that what is given for you. The problem is like this. Find the ratio of velocity of a sound in helium and nitrogen. As I told you, helium is monoatomic, whose gamma is 5 by 3. And nitrogen is diatomic, whose gamma is 7 by 5. Molecular weight of helium is 4, helium 2 4. Molecular weight of nitrogen is 7, nitrogen is 7, 7 2 is 14 is the atomic weight. So the molecular weight is 28. So knowing these basic facts, we can further study how can we understand things like he also given the temperatures, right? At different temperatures, at at the helium at a temperature, say you can call it like a T1 is at 27 degrees centigrade. I have to convert into Kelvin by adding 273. That's 300 Kelvin. T2 is 127 degrees centigrade. Again, we have to add 273 to convert that into Kelvin. That is 400 Kelvin. Knowing all the values, I can now use a formula. Velocity of a sound in first case to the second case. That is velocity of the sound first when compared with the helium by nitrogen is directly proportional to gamma of the helium by gamma of the nitrogen, and R is constant. Directly proportional to temperature of the helium by temperature of nitrogen, and molecular weight is inversely proportional. So molecular weight of nitrogen by molecular weight of helium. These are the data that we need to substitute. Let us substitute. Helium gamma is, as I told you, helium is monatomic. Gamma is 5 by 3. Gamma of nitrogen is 7 by 5. Temperature of the helium is 300. By that of nitrogen is 400. Molecular weight of nitrogen is 28. Of that of hydrogen is equal to 4. So you can simplify this and find an answer for that. So the zeros can be cancelled. This is of 7 times. 7 fours is 28. So 5 by 3, it is reversed. Again 5 by 7. This is 3 by 4. And there is a 7 here. 5 by 3, sorry. This is reversed, right? So it becomes 5 by 7. So this 7 and this 7 can be cancelled. This 3 and this 3 also can be cancelled. So that is square root of 25 by 4, or in the ratio of 5:2. So velocity in that particular case is in the ratio of 5:2. So solving a problem is not a big deal. I want you to understand the concept and how can we rewrite the formula, this formula gamma p by rho, into a different set of a formula depending on the requirement to solve the problems. That's it. Thank you for watching.